Now design a multi-tape Turing machine for the language L is equal to a power n, b power n such that n greater than or equal to 1. Now here we have to use multi-tape Turing machine. So we'll be given with the string that belongs to this language, say for example AA, BB and a blank. Here since we can use multi-tape for keeping the input. I'm going to follow this logic. For keeping the input, I'll be using one tape and I'll be using two more tapes. Let it be tape 1, tape 2 to hold only A strings. So I'll be copying whatever may be the number of A's that is placed in A tape will be copied in tape 2, and whatever is there, the number of B's in tape 1, that will be copied in tape 3. So when I'm going to read a in tape 1, I'll be copying that A here. Again another A that will be copied here. Now B comes, that will be copied in tape 2. Another B comes, that will be copied in tape 2 likewise. So any number of A's, n number of A's I'll be copying in tape 2 from T1, and again n number of B's I'll be copying from tape 2. Now next thing is, I won't disturb this tape 1. I'll be checking for each of this A, I'm having a B in tape 2 and tape 3. I'll be doing the matching only in tape 2 and tape 3. For every A, I'll be checking whether there is a B by moving it one step to the right hand side. Or likewise, so here again I can use a 2A infinite tape. So the first will be blank. So after copying, I'll be my tape 2 will be here, and my tape 3 will also be in the extreme right side blank. So I'll be moving every time one step to the left until this B is reached. So if both of them is reaching to the extreme left hand side blank, then it means that it is having equal count of A and B. Then I'll be stopping. While traversing backwards, while traversing forward, I'll be copying the contents in T1 to T2 and T1 to T3 in case of B. While traversing to the left hand side, once it is matched, I'll convert that into blank. And I'll be halting. Once it is done, I'll be halting. This is the logic we are going to follow for designing a multi-tape Turing machine for the given language. So initially we'll be in state Q0. So we'll be repeatedly doing it. What? When T1 is reading a, replace that with A and move towards right. Simultaneously, you need to convert the blank in T2 to A and move towards right. But nothing should happen. So blank will be replaced with blank and nothing will be happening. The header will be pointing to T3 itself when you are copying the contents of A. The same thing has to be repeated. When T1 is reading B, it should be replaced with B and move towards right. There should not be any operation in T2, but in T3 the same has to be copied. That is, the blank will be replaced with B and it will be moving towards the right. So this will repeat till nothing is there in tape 1. That is, when the tape 1 reaches the extreme right side and reads the blank. At this point of time, you have to replace tape T1. This is for T1. Replace blank with blank and do nothing. Okay. Now again, at that particular time, your T2 also will be reading a blank. So you do nothing, and you start moving towards the left hand side. I'm sorry, you have to start moving towards the left hand side in T2. And when blank comes, you replace that with blank, move towards the left hand side. This is in Q1 state. So when we are in state Q1, what is happening? We have copied all the symbols, A symbols to T2 and all the B symbols to T3. So at this particular point of time, suppose you have two A's and two B's in tape 1. That A will be copied. All number of A's will be copied in T2 and all B's will be copied in T3. All B's will be copied in T3. This is what will be happening at this particular time. And the header will be pointing here. The header will be pointing here in all the tapes and it will be moving one step left now. Now, in this particular point, we are checking whether there is equal number of A's and B's. There is no role to be performed in tape T1. So T1 let blank replaced with blank and no operation. In T2, if you have a A, replace that with blank and move towards right. And in T3, if you have a B, replace that with blank and move towards left. In that case, you are converting this to B and this also to blank and moving towards the left hand side. So this will repeat until this blank comes. If it is having equal number of A's and B's, then obviously when tape T2 is coming to the extreme left side blank, T3 also will come to the extreme left side blank. At that particular time, we need to halt. So if T1 is having a blank, replace that with blank and halt. T2 is having a blank, replace that with blank, halt. T3 is having a blank, replace that with blank and halt. So this is going to be our final state. So when this is the process of checking for every A, one B is there. This is the step which will check. And simultaneously, we'll be replacing this with blank. So at the end, we will have the same input string there and all this will be replaced with blank. So this is an example in which we are using 3 tape to design a Turing machine to accept language L is equal to A power n, B power n such that n greater than or equal to 1. Similarly, you can try and design a multi-tape Turing machine for the language L is equal to A power n, B power n, C power n such that n greater than or equal to 1. Obviously, we will be using one tape to place the input, another tape to place n number of A's, T3 tape to place n number of B's and T4 tape to place n number of C's. The same logic you can follow as we have followed here. You try to design a multi-tape Turing machine for this language. Thank you.